Okay, so now let's continue here. Exam to review. Question 20 here. The wavelength of light has a frequency of 1.20 times 10 to the 13th per second, right? So the question is, what's the wavelength in meters? So what's the formula for frequency? Is speed of light divided by wavelength in meters, right? So the question asks for wavelength, so let's just rearrange it here. So if wavelength is speed of light divided by frequency, right? So the speed of light is 3.00 times 10 to the 8, will be given to, right, meters per second, divided by the frequency that was given, 1.20 times 10 to the 13, second to the minus 1. So they're going to cancel seconds with seconds. So your unity here will be already in meters. That's exactly what the question is asking. So make sure you do this math here. Divide this by this. So some calculators, you need to add parentheses in the denominator here. So type this number in the calculator. Like my calculator need to do like 3 to the 8th, right? Divided by, oops, yeah, I'm the same. 3, 8, divided by, for mine, I need to type parentheses, and then 1.2n exponential to 13. And if the parents, and then you have your answer here, right? So the same thing. Maybe your calculator needs or not. Okay, so question 21. So what's the correct ground state electron configuration for copper? So copper is one of the exceptions, right, that we saw in the electron configuration. So copper, how many electrons we have in copper? Copper has 29 electrons, right? So copper, 29. The electron configuration will be, so follow here, right? So 1 Sc2, 2 Sc2, then 2p6, next 3 Sc2, next 3p6, next 4 Sc2, and then let's count it here, right? 2 plus 2, 4 plus 6, 10, plus 2, 12, plus 6, 18, 4 Sc2, 20, then 3d9 will be, right? Oh, 3d10 want to be 3d9 initially, right? Because you needed 29. All right. So copper is one of the exceptions, right? That the electrons in the copper will be more stable in heavy field and field here. So there's one electron here from 4s2 will be making 3d10 here, and 4s2 will be for s1. Because here will be just one electron, and the 10 will be completely full filled, right? All 10 electrons. So the atoms like copper will be more stable in 4s1 3d10 than would be in 4s2 and 3d9. That's why copper is one of the exceptions, right? And then we can answer here which one is. Okay, so argon, right? Noble gas, in brackets, is a short-handed configuration. So argon has 18 electrons. So let's see. This portion here will be your argon portion, right? that this portion here has 18 electrons, as argon, 2 plus 2, 4 plus 6, 10, 12, 18. So the answer will be argon, then 4s1, and 3d10. That should be C, right? Right? Okay. And the next one now is about the molarity. So let's go back to chapter 4. So what's the molarity of a solution made by dissolving 23.4 grams of sodium sulfate in enough water to form 125 milliliters of solution? Okay, so molarity is moles divided by volume in liters, correct? Okay, so need to find the moles first. What's the formula to find moles? Moles is mass divided by molar mass, correct? Okay, so the mass given, 23.4, and the molar mass of sodium sulfate, go to the periodic table, find what's the molar mass of sodium. Sodium is, right, around here to 23. So sodium is 23. We have 2 sodiums here. Sulfur is 32. You have just 1 sulfur. And the oxygen is 16. You have 6 oxygens here. Oh, sorry. Sorry, 4 oxygens here, right? So 23 times 2, 46. Then 32. And then here it will be 32, 16 times, so gonna be 64. And I'm gonna add up everything here, right? How much should be the molar mass of sodium sulfate here? 43, 46, plus 32, plus 64. I round the number here just to be faster here. 142 grams per mole. So the mass here was given, right? Let me divide here. 23.4 grams divided by the molar mass of sodium sulfate, 142 grams per mole, right? Send to this division here. So 23.4 divided by 142 will be, so the moles here, this part should be 0.16478 moles. You see here in the beginning of the class, so here we did not finish, right, yet. So that's why here I'm not too worried about the numbers of significant figures yet. Only in the last, only the final here. Okay. So now that you calculate the moles, 0.16478 moles, right? Divided by the volume in liters, you have 125 milliliters. From milliliters to liters divided by 1,000 will be 0.125 liters, right? So the molarity will be this moles, right, divided by the volume of the solution in liters should be 132. 1.32, right? Around to 3 significant figures should be letter A here. So molarity, moles of solute divided by volume of the solution, right? Then question 24. How many milliliters are needed of 3 molar are needed? How many milliliters of 3 molar are needed to make 450 milliliters of a 0.10 molar sulfuric acid. So here you have different volumes, different concentrations. So you know that here you have a dilution. So we're gonna have molarity of the concentrated solution times the volume of the concentrated solution, right? Times the molarity of the diluted solution, that's gonna be the one of lower concentration, times the volume of the diluted solution. So the concentrated solution is the higher concentration here, that's 3 molar, right? The question is asking the volume of the concentrated solution, so we do not know VC, right? Then the mid MD is 0.10 molar, right? The concentration of the diluted solution times the volume, the final volume here, the volume of the diluted solution is 450 milliliters. Then we are going to find VC is equal 0.10 molar times 450 milliliters, right? Okay. Then divide by 3 molar. So you're gonna calculate here. Molar cancel out with molar. You know your final answer will be something in milliliters. So this one, I'll let you to do this math in here, okay? All right. All right, okay. So what's the question 25? What's the molarity of a sodium hydroxide solution if 48 milliliters of neutralizes 35 milliliters of 0.144 sulfuric acid? So here you have different solutions, right? Different compounds. Here you have sodium hydroxide, and here you have sulfuric acid. So here it's not dilute solutions. Now you have here a titration. Titration. So when we have a titration, we need first to write the reaction, right? So we have sodium hydroxide plus sulfuric acid, right? The products you have. So strong base, strong acid will make salt and water. The salt here will be sodium sulfate plus water. Now, our reaction, you need it to balance, right? So here you have 1 sodium, here you have 2, so let's add number 2 here. So now what else change it? So how many hydrogens do you have here? In the reaction, you have 2 times 1, 2 hydrogens plus 2, 4 hydrogens, right? So we also need 4 hydrogens in the product side. Okay, so now you have 2 sodiums. Oxygen 2 plus 4, 6. 4 plus 2, 6. And hydrogen, we already checked, that's 4. And sulfur, 1, 1. Okay, so now the reaction is balanced. What's the next step here? So in a titration, like neutralization, titration, we're gonna follow the same. We're gonna find the moles of the portion that was given the volume and the molarity. So let's find the moles here first. Find the moles, you're gonna multiply molarity times volume in liters, right? So the molarity was 0.144 molar times 0.035 liters, right? Let's find this moles of sulfuric acid. The question is asked the molarity of sodium hydroxide but you won't have information right now, everything for the mole that you can calculate the moles of sulfuric acid. So how many moles? Times 0.035. So now we have 5 moles times 10 to the minus 3 moles of sulfuric acid. But the question is asking for the molarity of sodium hydroxide. Now, you are going to do what do you need to do? How can you do by converting the moles of one compound to another one? So when you have it, but when you do these conversions here, this is when you needed to use the molar ratio that's you see in the a balanced chemical reaction. So you have 5.04 times 10 to the minus 3 moles of sulfuric acid, right? But the question is that for the molarity of sodium hydroxide. Now let's do the mole ratio. Okay, so right now here you have the moles of sulfuric acid. So the moles of sulfuric acid stays on the bottom here. So how many moles you have here? When you don't see anything, you know that you have 1, right? So here 1 moles of sulfuric acid. You want to convert from moles of sulfuric acid to moles of sodium hydroxide. How many sodium hydroxide you have here? So 2 moles of sodium hydroxide, right? So let's do the calculation here. Just multiply by 2. So it's going to be by 10. So 0.01008 moles of sodium, sodium hydroxide, right? Okay, but the question is asked for molarity. How can you calculate molarity? Take moles divided by the volume. What's the volume of sodium hydroxide? 48 milliliters. So with this number here now, to find the molarity, we are going to take the moles, sodium hydroxide divided by the moles divided by the volume. That is, in liters, will be 0.048 liters. Let's divide this by the answer should be, right? Make sure you do the math. Just already did the calculation here for you, right? Just need to divide this moles by this volume here. But now, attention here, right? So the question, we have 3 significant figures, and 3 significant figures. That means your final answer should have 3 significant figures. All right? Okay. So 26. Calculate the change in the internal energy for a process in which a system absorbs 140 joules of heat from the surroundings and it does 85 joules of work on the surroundings. So now here, question 6 is chapter 5 is about thermochemistry. So the question here is the same idea that we did on question 20. What was the question? Oh, here, question 6. The same idea, actually, right? The same formula, delta E is equal heat plus work. Now, we're going to pay the attention to the keywords here. So calculate the change in the internal energy for a process in which a system absorbs 140 joules of heat from the surroundings and thus 85 joules of work on the surround. So absorbing, so here be positive, right? And then it says that the process does the work. So minus 85 joules here. And I'm gonna let you guys to do this math here. All right. Question 7 is also about chapter 5, that's thermochemistry, but here is about using stoichiometry to solve this question here. So for question 6 was using like internal energy, right? Question 27 was using stoichiometry. So first, let's check if the reaction is balanced. So every time when you have a chemical reaction, you need to check if the reaction is balanced. One carbon, okay. 4 hydrogens, 2 times 2, 4 hydrogens, okay. Then oxygen, 2 times 2, 4 oxygens. We have 2 here, plus 2. So yes, this reaction is balanced, right? Now, let's start with what was given. It says, have the combustion of methane here, right? So how much heat is released when you burn this amount of methane? You know when you burn 1 mole, this amount is released. But you don't know yet how much will be released when you burn 4.50 grams. That means you need to know how many grams you have right here. Okay, so 4.50 grams of methane, that's CH4, right? So from grams to moles, divide the mass by molar mass. So you know that each 1 moles of CH4 was the molar mass of CH4. Carbon is 12 plus 4, 16. That's around 16 here. 16 grams per mole, right? Okay, so when you go grams of CH4, from this step to this, you convert from grams to moles, right? So now, what do you know here? For each 1 mole of methane that's combusted, right? You know that release minus 890 kilojoules. So let's do it here. Divide 4.50 by 16, then multiply by minus 890 kilojoules. And so have your answer here, right? So 1 mole. So this amount that's released for 1 mole. This is why I need first convert it from grams to moles, and then from moles to know the amount of kilojoules here. All right? Okay. So now finish all multiple choice questions, right? I will stop here and then I'm going to record one just showing the pre-response questions, okay?